So next, actually, very important topic is actually the serial communication. So this serial communication, why we require microcontroller is like, today also I was working for one of the applications. For instance, you have this microcontroller. Okay. Now you want to talk to another IC, like maybe ADC, DAC, or even LCD for that instance. So you need to have some protocol, right? So if I just send some data from microcontroller to ADC or microcontroller to DAC, it won't understand, right, what the data is. So we need to have a certain protocol for communication between one device to another device. Okay. So that we will be dealing in. There are like two ways of communication. One is serial communication. Another is parallel communication. So in the serial communication, what I do, I just send one bit of information, one line of information in the serial. Okay. Like for instance, if I want to send 0x87, then I will be sending, first I will send 1, then I will send 0, 0, 0, then 0, 1, 1, 1 by bit I say. This is serial communication. If I come to parallel communication, what I do, I will have 8 parallel lines. 8 parallel lines. 8 parallel lines. If I want to send this 1001, so I will be sending in one cycle itself. 1, 0, 0, 0, 1, 1, 1. So from TX to RX, I send parallelly all the information. Here it is serial. So from TX to RX. So can you tell me which is faster here?
Serial.
Serial, actually, I'll be sending, for example, if I want to send this data, first I will send 1, then I will send 1, then I will send 1. So first 1 second I will be sending this, 2 seconds this, 3 seconds. So if I want to send, if I consider like 1 bit has 1 second of delay, then in order to send this data, I need 8 seconds of time. But here, if you see, from TS to RX, everything in one shot itself, 1 second itself will be sent. This here to here, here to here, here to here. Everything is available at first second itself in RX. So which is faster now? The parallel communication is faster because simply everything in one shot itself, right? But what is the disadvantage? Can you think? What's the disadvantage of serial communication? What's the disadvantage of parallel communication? So serial communication requires one wire, whereas parallel communication requires multiple wires, more pins, right? Consider 8051. So out of that 40 pin, the serial communication will be using just single pin, whereas your parallel communication will be using 8 pins, right? It requires
Yes,
more
sir.
pins, correct? And we have another type of communication. So this is like serial versus parallel. Another is asynchronous versus synchronous. In asynchronous communication, what we do, we just send the data. Like if I want to send 1, 0, 0, 1, I just send the data. At the reception end, I can sample anyway. I can interpret this as 1, 1, 0, 0, 0, 0, 1, 1, 0, 0, or I can just interpret as 1, 0, 0, 0. Here, there is no reference of clock. No reference of clock. If there is no reference of clock, then it is asynchronous communication. In synchronous communication, what will happen? along with this data, I will also send clock. So now I can accurately say if that this rising edge, I will get 1. This rising edge I can interpret as 0. This rising edge 0. So this rising edge 1. So synchronous communication, always the data will be sent with clock. In asynchronous communication, what we do, we will just send the data. There is no clock. Did you get this difference?
Yes, sir.
Oh. And we have another type of communication, half duplex, full duplex, and simplex. So simplex communication is something like I have a TX and I have a RX. Okay. If I am sending only from TX to RX in one direction, it is simplex. Okay. If I have like bidirectional bus. Okay. So this is like I will be sending. So TX will be sending from here to the RX. When this is happening, so RX will just listen. Once this transmission is done, so RX will send from TX. So here, the reception and transmission cannot happen simultaneously. But using the same wire, TX can allocate some amount of time for it, like it can send the data. And RX will, in the assigned slot for it, will send back to the TX. Okay, it's a bidirectional, but actually, like together at a time, both TX and RX cannot communicate. This is which mode of communication? Half duplex. Okay. Next mode, from TX, it will receive RX, and it also reverse direction. I will have RX also TX can happen. So at a time, both at a time, it can communicate TX and RX. So this is actually full duplex communication. Clear?
Yes, sir.
So in 8051, in your syllabus, we mostly focus on asynchronous communication. Okay, we do not focus on the synchronous, asynchronous communication. Okay, so the protocol what we use or what we discuss, that is UART. That means it is universal asynchronous receiver and transmitter. Okay, and if I just show you the block diagram of them, how the transmission and reception happens, so you should tell me whether it is a full duplex or half duplex.
Yes, sir.
So this is the block diagram. So it transmits, receives, this transmits, this receives. Which mode of communication?
Full duplex.
Yes. UART is a full duplex. Okay. The format of the data in UART, like when I say whenever I'm transmitting some data using UART, then it is this way. I mean, we'll straight away put the screenshot. So first I will send the stop bit. Okay. Then D7 to D0. Total 8 bit of data. I will transmit. Then actually, okay. So this is actually, it's a reverse way. Okay. So start bit. So you have to interpret from right to left. First I'll send the start bit. Then I will send 8 bit of data. Then I will send stop bit. Okay. So this is how we transmit. So totally how many bits I am sending? 10 bits. Okay. 10 bits. Start bit, stop bit, and 8 bits of data. This is which protocol I am talking about? UART. Okay. Hopefully you're getting what I am trying to say.
Yes, sir.
So now if someone asks you to send, so this is actually like if I want to, for example, if I want to send 3A through UART, then I'll be sending start bit. So it is actually followed this way. Okay. Then what I'll send? MSB first, correct? So it is 0, 0, 1, 1. Then I will send A 1 0 1 0. Then I will send stop bit. This way I send. Clear?
Can you tell once again, sir?
Yeah. So for instance, if I want to send 3A from microcontroller, you have, for example, you have microcontroller. From this microcontroller, you want to send to DAC 3A. So what I'll do, I'll send first start bit I will send. Then what is 3A? 0 0 1 1 1 0 1 0. This is 3A, correct?
Yes, sir.
I'll send this data. Then I will send stop bit. This is how I send the data. Okay. But for example, if I am sending 10 bits in 1 second, whether this 10 bits also useful for me here? Here, if you consider I am sending 10 bits. Can I say 10 bits per second? Data rate is 10 bits per second. Did you get my question? If I am sending 10 bits here, can I say 10 bits per second is the data? No, right? Because out of that, how many bits is useful for me? Only 8 bits is useful. So the data rate is 8 bits per second. But what is this 10 bits? 10 bits per second. I call it as baud rate. Okay, baud rate. So baud rate is the actual transition of the data. Transitions of the data occurs. But the data rate is the useful data what we are sending. The rate of the useful data rate what we are sending. Okay. So in 8051, there are various data rates or baud rates are supported. That is 1110 bits per second, 150 bits per second, 300 bits per second, 1200, 4800, and 9600. Okay, and 19200. Okay, and in order to achieve this baud rate, we have to use the timer what we have studied previously. So we are using timer 1 for achieving this baud rate to keep the reference of this clock. Okay.
Yes, sir.
Okay. So the UART frequency, the frequency at which it is operating is given by machine cycle frequency divided by 12. And this machine cycle frequency is given by crystal frequency. Okay, machine cycle frequency divided by 32 and crystal frequency by 12. Okay, so here we can take one example. If I have crystal frequency xtal is 11.0592 megahertz. Okay, can you compute the machine cycle frequency now?
Divide by 12.
Yes, how much it will come? And also find UART frequency.
Point 92.
Yes, that is actually in kilohertz, 921.6 kilohertz.
921.6.
And UART frequency is divided by 32.
30.
That will become 28800 hertz. Okay.
Yes, sir.
So here actually we can go with the timer 1 settings, right? Whatever we can use from the table. So we have to use the timer 1, okay, TH timer 1 in mode 2. What is mode 2 actually? It is 8-bit auto reload, right?
Yes,
Can you
sir.
just recall what we had studied? It is 8-bit and auto reload, mode 2.
Yes, sir.
Okay. So this you have to remember. I mean, you can calculate also what should be the baud rate and what is the TH1 settings. So if you want 9600 baud rate, then TH1 settings should be FB, 0x FB. If you want 4800 baud rate, so this whatever the things I'm discussing, that is with respect to 11.059 megahertz. Most of the time, whenever UART supported the microcontroller, we take this crystal. Okay, so 4800 you will have 0x FA. 2400 will have 0x F4, and if you want 1200 baud rate, then it is 0x E8. Okay.
Yes, sir.
So this is regarding setting the clock frequency. This is only related to setting the clock frequency. Now, when I talk about UART, so for example, I said if I want to send 0x A9, okay, so I need to have some register where I need to push this data. It's like just setting the clock frequency. Now, where I have to push this data, or like where I have to receive this data. So the data, okay, the data register is actually SBUF. SBUF is used for data register. SBUF, the buffer. Okay, this is actually 8-bit register. 8-bit register. Okay, so it is actually whatever the data you transmit through TXT line, whatever the data you receive from RXT line, that will be stored in SBUF. Okay, so for example, now if I want to send the data as the character D, ASCII D. If you want to send character D, you have to send like this. Hash, and in the code you have to send like this. So what I do, move SBUF hash D. Okay, so this way I have to send. the character D. Clear?
Yes, sir.
And for instance, if you are receiving any data from the RX, so you have to type like this: move A, comma, S bar. So whatever you receive, right? Whatever you receive, that will be stored in this way. This is in the receiver side. Clear?
Yes, sir.
So now, similar to our timer, we have a control register, that is SCON register. SCON register, that is for controlling the serial communication. So here we will have SM0, SM1, SM2, REN, TB8, RE8, T1, RI, TI, RI. These many bits, total 8 bits will be there. Okay, 8. So this SM0 and SM1 used for selecting the mode of operation. Mode of operation. And this SM2 is used for multiprocessor communication. Okay.
Yes, sir.
So this REN, whenever we receive the data, right, this is actually used for clearing the like whether to enable or disable the reception, whether you want to receive or not. This is a receiver enable bit. Okay. So TB8, RB8, usually it's a user defined bits. It will not be used. So T8, this one, right? T1, it is actually transmit interrupt. RI, it is actually reception interrupt. Whenever the data transmitted, TI will be enabled. Whenever you enable the interrupt and you receive some data, receive interrupt will be enabled. Okay.
Yes, sir.
So most of the time, I mean, other modes are actually not widely used. Most of the time we use serial mode 1. That is actually SM0 is 0, SM1 is 1. So here in this mode, we will have 8 bit of data and one stop bit and one start bit. Clear?
Yes, sir.
So now we will see the sequence of programming. So first actually, first we have to load the TMOD register, right? If you want to enable the timer, what we have to do? We have to load the TMOD register. And we have to set to which mode? We have to set into mode 2, correct? Timer 1 in mode 2, correct?
Yes, sir.
So for that, we have to load TMOD register with 20H. Next, TH1, we have to load based on what data rate we are operating. So here actually we have like various operations, right? So we have like 400. So whatever the value, whatever the baud rate we want, so with that value we load it here. Okay, based on baud rate. Based on baud rate, we load the data. Then SCON, serial controller register, we load with value 50H, which means if you come here, so SM0, SM1, we have to always operate mode 1, right? So this will become 0, 1. SM2, I will keep 0. Okay. Receive enable, I have to enable the receptor. RE1, I'll keep it 1. And TB8, R8, everything I'll keep 0. I mean, right now we will not enable the inputs. So it will become 50H. Correct?
Yes, sir.
Okay. Then I will set TR1 to high. TR1 to high. What is the meaning of setting TR1 to high? I will start timer. Once I start timer, I will keep monitor the T1. Okay, I'll keep monitoring this T1. So then, wherever the timer reaches, the overflow flag happens. This T1 is nothing but TF, right? TF basically is an overflow flag. Wherever overflow flag happens, I will push the character to yes bar. Yes. Okay. Then I will monitor TI. So TI basically says whether whatever the character I pushed into yes pub, whether it is completely transferred. So once that T jump if no bit, usually I monitor this key. So if this TI is clear, is completely transferred, then I will go to transfer next byte. That is again, I'll go to this step. Clearing the TR1, start the timer, then push the data to SPUB, monitor TN. It will keep happening. Any doubt here?
No, sir.
Okay. Okay. Then, if possible, tomorrow morning I will take another session. There we will discuss some of the programs related to UART. Clear?
Yes, sir. At what time, sir?
Maybe around 7 we will plan. Okay.
Okay, sir.
Tomorrow 7 may not be possible. Around afternoon, is it fine?
Yeah, sir. No problem.
Okay. Did you get the date for exam?
Yes, sir.
When is the exam?
August itself, sir.
August when?
Second week, sir.
Okay. Okay. So by 25th or so, I will try to finish this theoretical aspect. Then we will go through problems in the question papers. I mean, we will keep revising the things. Okay.
Okay, sir.
Okay. Okay. Thank you.
Thank you, sir.